Hello and welcome to Scanware's Academy, a programme of learning sessions based on electrical safety which we will be producing regularly to help educate on a very serious topic. We will also be running live question and answer webinar surgeries, so should you have any questions on today's session, then we are here to help. The date for the first surgery is on screen now. If by the end of today's session you have any doubts as to your arc flash requirements, then register for our free electrical safety health check. A Scanware representative will visit you on site to help complete the initial health check, and we will determine your risk level. Now for a little housekeeping. The webinar will be available to download after the session, so don't worry too much about taking notes. Check your email for the links that we will send you, including the date and information of the first surgery. Be sure to join us on Twitter using the handle @Scanware and join our conversation using the hashtag #SavingLives. I'd just like to take a moment to thank everybody for tuning in. The attendance today is really great and I'm so pleased that so many of you are taking this topic seriously. Which leads me nicely now to introduce our guest speaker. We've got Graham Harvey here with us. Graham, hi, nice of you to join us.
Nice to be here, Lana.
Could you just tell me a little bit about your background?
Well, I graduated as an electrical engineer a long time ago. I've had a really fantastic career. I've been able to work all around the world, the Americas, Asia, Middle East, Europe, with lots of different people and with so many different cultures. But one of the most common links I found through all of this was when it came to electrical safety, nobody actually understood it. So about 20 years ago, I actually got into it. And what I've been trying to do is to develop electrical safety systems, procedures. I've generated lots of training courses, and I also carry out electrical inspections and audits to help people improve their systems. However, I've also had to do a lot of accident investigations involving electrical incidents, and some of them unfortunately included deaths. So I'm extremely passionate to raise the awareness of electrical safety so people understand the hazard and can actually arm themselves to go to work more safely.
Yeah, absolutely. And that's why we're here today. So we'll get on with today's topic, which is arc flash, myths, facts and folklore. So what is an arc flash?
Well, electricity is one of those really unique hazards. Under normal circumstances, you can't see it, you can't hear it, you can't smell it. But it's really, really deadly. And if people ignore it or forget about it, there's dire consequences. So an arc event is really one of the most deadly and least understood hazards of anything to do with electricity. It's low frequency, a high consequence event. It's caused when the electric current flows through the air gap between the conductors. And to put it mildly, it's like a hand grenade going off in the room. An arc event consists of very bright light, a lot of noise, and a blast that contains a lot of heat and a fireball, a plasma ball. As the arc develops, it gets hotter, the resistance in the circuit drops, and more current is actually drawn in. And it will continue to do that until either something in the system either trips, melts, or vaporizes. And the alarming thing is that happens within fractions of a second. So for those of you who have not seen an arc flash, we've got a small video now just to demonstrate it.
Okay, so now we've seen what an arc flash event is. What causes this to happen?
Well, there's lots of different causes, but I'll just go through a few. By far the biggest one is human error. A lot of people will be working on a circuit and they actually think it's dead, but actually it's not, it's alive. People also get distracted, and when they get distracted, they touch things they shouldn't touch. And then another human error really is when they switch off the cubicle at the front, they walk around the back and open up the wrong panel. Another thing is inadvertent contact. So if people, occasionally we do have to work on live equipment, and we should be using insulated tools. And if you don't use insulated tools and you manage to touch the buzz bars, then you can cause a short.
Sorry, a buzz bar, can you just tell me what that is?
Yeah, the buzz bars, instead of having cables in the back of the cubicle, we have either copper or aluminium.
Right.
And they're 2 or 3 inches wide and they're 1/4 of an inch thick. And what they do, they actually carry the voltage and the current. Another cause is insulation failure. So we could have damaged insulation, or we could have equipment age, or again, we could have environmental issues which actually affect the insulation. Then we can have things like equipment failure. So that's just general age, wear and tear. But it can also be aggravated by having substandard parts that have been replaced during servicing. One of the biggest issues, though, is lack of maintenance. And unfortunately, in this day and age, when companies have to cut costs, maintenance is usually one of the first things that go. So unfortunately, when there's no maintenance, we get dust build up on the buzz bars. Other impurities get in there. And if they actually get airborne, what happens then, the arc can form across the bridge. And then finally, another, not so much common cause, but another cause is because this equipment tends to get warm, it attracts things like rats, mice, squirrels, snakes, and they crawl in. And again, if they crawl across the buzz bars, short 2 out, we've actually got an arc flash.
Okay. And the myths surrounding arc flash, just talk me through those.
As I said before, I've worked around the world and I've talked to loads of people. And people say, oh, an arc flash is a myth. I've never heard of it. I've worked here for 20, 30, 40 years. I've never seen one, never heard of one. So why are you trying to change things now? Secondly, we get another misconception is, I'm okay, the doors are closed. Well, as we saw, when an explosion happens, the doors can actually get blown off. Other people will say, it can't happen, it's only low voltage, it's only 240 volts. It can't happen. It can, and I've actually seen it. And about 3 or 4 years ago, I investigated an accident. Again, it was a 240 volt flash. But when the plasma ball came out, the gentleman concerned was actually wearing a gold necklace. The necklace heated up and it actually then melted into his skin. And then the final part really is people get mixed up between flame resistant and arc proof clothing. They think it's the same, but it's not.
How so? How is it different?
Well, flame resistant clothing does exactly what it says on the can. It actually resists catching fire. Whereas arc proof clothing also resists catching fire, but it has thermal effects. So when the plasma ball comes out and all that thermal energy hits the person, it's actually stopped by going through and it can't actually burn the skin. So that's actually known as the arc thermal protection value. So ATPV, for instance, and we'll come onto that a little bit later.
So what is the folklore?
Folklore is what people believe. It's the local culture. So people say to me they're qualified, trained and competent, and we don't have electrical accidents here. And in reality, that's not true from my experience. People do have electrical accidents, but they don't report them because there's no physical injury. So the EFI actually did a survey of 1,000 electrical engineers, and they asked a simple question. Have you received an electrical shock in the last 12 months? And 98% of the people said, yes, we have. The other thing is that people think, I'm okay because we've got upstream protection.
What is upstream protection?
Well, upstream protection can take several forms. It's either fuses, relays or breakers that actually limit the current coming down the circuit. It's very similar to a fuse in your house. Other people will say, well, it's only careless people that have accidents. Again, it's not true. People get distracted, they get startled, they get interrupted. So all the time you have to be aware of the unexpected. And the last real folklore that I would really like to talk about is arc flash PPE. And again, I've heard all the excuses why people don't wear it. It's too hot, I've got no dexterity, and really it's only for wusses. So that's the peer pressure keeping in. And I've been to factories where people have been issued with arc flash PPE and it's still in its bag.
So on that note, let's go over and take a look at some of the garments that we brought with us today.
Excellent.
Okay, so let's take a look at some of the Strata garments that we've got with us today. We've got the new SFX 300 shirt, which I think you probably agree with me, it looks really nice, really stylish. It's got this lightweight moisture absorption fabric, which obviously makes it really cool for you to wear.
Yeah, I've got to admit, it's very soft to the touch, and what I really like about it, you could wear it in the office or out in the field. And again, to make sure everybody's in a compliant point of view, you can instantly see that it's ARC Cat 2 rated.
Yeah, absolutely, which is so important, isn't it?
It is.
And here we have the SFX 273 trousers. You can see that we've got the elasticated waistband here, which obviously makes it really comfortable. And the leg has been articulated so that when you sat down kneeling, it really takes into consideration the pinch points. And like you pointed out, again, easily identifiable, which is really important.
Yeah.
Okay, so now let's move across to the Strata SFV 839 overall. As you can see again, we've got this lightweight fabric and under the arm we've got the easy arm gussets. This means that when you're moving about and you're raising your arms, there are no pinch points and that it fits really comfortably when you're working throughout the day. And again, we've got the easily identifiable arc rating there on the leg.
Yeah, one of the things I do like about this coverall is this type of collar. It's always been a weak point that people don't always do their collars up. So what made you come up with this type of design?
That and actually all the other features come from the Friends of Strata campaign.
So what are the Friends of Strata?
Friends of Strata is where our garment technicians go out on site visits and we actually get the guys wearing the clothing and then the feedback that they give us from the wearing of it, we actually implement that into the clothing.
That's an excellent innovation. If we look at another thing which I think is quite good as well, we look at the flash mask. Again, it's lightweight, it's wicking material, so that means it takes all the moisture away from the body, and it's very comfortable in hot weather. And if we move on to the visor, this is quite again a new technology. Previously, all arc visors were either green or orange, and one of the complaints was, I can't actually see what's going on. But this is Scanware's true colour visor, and when you actually look through it, you actually see the colours as they are. And again, it's got the chin guard, which ensures or helps prevent that the arc flash doesn't actually roll up inside. So the final thing where people say, I don't like wearing PPE is because they say they lose dexterity on the gloves. So really there's 2 points that happen here is that people actually are wearing the wrong size glove. And the way to see if your gloves are the right size is to actually measure the palm of your hand, and that will actually give you your glove size. And then the other important thing is to make sure you've actually got the right rating, voltage rating. As the voltage rating goes up, the gloves get thicker, and then they do get a lot more difficult to wear. And finally, really, once you've finished with the gloves, it's not a case of putting them back in your toolkit. They need to be stored properly and correctly. So they should go back into their bag so they don't actually get contaminated from anything in the workplace. The final message that we really have to get across is that you wouldn't see a fireman or an F1 driver going to work without PPE. And what we have to get across to our people is that we don't want to see electricians going to work that haven't got their PPE on.
Absolutely. So now I've got a video that I'd like to show you which reiterates exactly why PPE is just so important. Donnie Johnson was an electrician who almost died in an arc flash incident. The 5 minutes that he didn't take to put his PPE on cost him over 12 months of the rehabilitation and recovery process. This video was made by his wife to show the impact on their family and how life can change in a split second.
I got up early that morning. I was going to go to work to hook up a generator before the Hurricane Charlie moved into Florida. When I left that morning, I just figured it was any other day. I guess you don't wake up in the morning thinking that you're going to be in an accident.
911, what's your emergency?
We need an ambulance quickly. We just had an accident.
Sometimes when you get in that kind of situation, you kind of just have to break it down to the hour and the minute, because if you look at the whole day, it's pretty overwhelming.
What's the problem?
My coworker, he's badly burned. He just got caught in a fire.
Is he
flash arc fire.
Is he conscious?
Yeah, he's conscious.
I haven't done this 1,000 times. I've been an electrician for 20 years. I didn't need to wear my gear that day. I guess I was too good for it.
Can you tell me how many have been injured?
He's the only one, but he's in shock. He's got severe burns.
Donnie's service call was to go out, hook up the wires from the temporary generator into the main panel, which he's done many times over.
My job for the day was to hook up a 3,000 amp generator to a 3,000 amp electrical service. After I tested the generator power, I went into the main building electrical to test it. And I opened up a small panel for their main switchgear, their main breaker panel for the entire building. I clipped A phase with one alligator clip. I clipped B phase, and as I went to clip C phase, the meter blew up and blew a puff of carbon into the electrical box. Well, this set off an electrical explosion between all three phases.
We got a phone call that there was an accident. I was told that there was a flash in the electric room and the electrician on site was injured.
I didn't realize at that time how badly I was hurt. The one maintenance man told me later that he thought I was dead because there was no way somebody could stay alive through that explosion. Looked down at my arms and hands, and I realized I was really burned up this time.
They told me my husband was calling, but it wasn't. It was another man. And he just said, I just have to let you know your husband's been in an accident. He'll be going to Tampa General, but he is walking and talking. I just literally threw the phone, grabbed my purse, and ran. And all the way down the road to the hospital, I was wondering, who do I call? What do I do?
One of the first things I thought was, this doesn't happen to me. You know, this is something that you hear about in the safety films, or somebody's friend that had this happen to them. It doesn't really happen to me.
They didn't recognize him because he was charred black. That was hard to see. Then he started getting infections. And I remember sitting there being talked to as if he may not make it through this. His waking up was very slow. It was just opening the eyes at first and not really being able to talk. I think he, like the first day, he was asked to respond by blinking.
After that point, they tell me I was asleep for a month and a half.
Once he woke up, I felt like, okay, now we're getting better. Now it's on the way up. And I don't think that any of us realized how long the recovery would be.
One of the first memories I have is my son walking into the hospital room across the foot of the bed.
When I first talked to my dad after he woke up, I saw he was definitely still the same person, but his body was just so small and shriveled, and he'd been through surgeries at that point. Later on, the number would total to about 6 or 7, and he'd have to go through hours and hours of therapy and rehab. He had to relearn how to walk. He had to relearn how to use his arms.
You know, I told my wife once before we got married that as long as I had these, we would have money. Well, I almost didn't have these. I almost lost my life altogether because I wasn't wearing the protection.
Less than 3 minutes of putting on his safety equipment would have prevented him from being in a coma for over 30 days, as well as a year-plus recovery.
Being safe is a lot easier than putting yourself through and your friends through and your family through what my family and I and my dad had to go through. It's just easier to put on your safety equipment.
If he would have taken that 2 to 10 minutes of time to put the gear on, work a little bit slower, it really makes you think that it's okay to be a half hour late.
As fortunate and blessed as I feel today, I could have avoided all of this that I put my family through, that I put myself through, if I'd have just taken that 3 minutes to wear my PPE.
Graham, I've seen that video so many times, and yet it still sends such a powerful message out, doesn't it?
Yeah, and I think what everybody has to realise is Donnie was a really lucky bunny. There's lots of people who actually go through that experience, and unfortunately they die.
Yeah, absolutely. So now we've seen what the myths and the folklore can lead to, let's identify the facts that we should know.
Yeah, and as we've seen from the video clips, when an arc event happens, there's intense light, and it's really, really bright light. It will penetrate a number 10 welding filter. So that's the importance of actually making sure your visor is UV proof. The noise is plus 140 decibels. So that's like somebody putting a gun near your ear and letting it off. The temperature of the plasma ball is 19,500 degrees C. So that's hotter than the sun. And if you're actually wearing just ordinary clothing, there's a high risk you will just burst into flames at, anything up to about 10 feet. The blast is extremely powerful. It's upwards of 2,000 pounds per square inch. So that, if you're standing anywhere in the vicinity, could blow you off your feet. If you're on a ladder, for instance, it will blow you off the ladder, and that could result in other injuries. And again, I've investigated accidents where people have been blown off ladders and they've ended up with broken bones. Part of the blast, when the plasma ball comes out, it consists of vaporized copper, and copper expands at 67,000 times its own volume. On top of that, you get shrapnel, bolt heads, and anything else that's blown out of the cubicle. And the big thing about the copper vapor, if you're not wearing your face shield, and again, this is an accident I investigated not so long ago, your face will get just copper plated, and your hands if you're not wearing gloves. So the resulting outcome is 2nd and 3rd degree burns. And as we saw from Donnie's video, the healing time is months, it's not weeks. Again, I've investigated accidents where people's fingers, thumbs have been vaporized. And on top of that, because 3rd degree burns go very, very deep, infection can set in, and people have lost or had their fingers amputated anything up to 18 months after the event. Because of the light and the noise, we could have suffer from blindness or deafness. It could be short-term or it could be permanent. The other problem is with burns, you end up having to have skin grafts. And with skin grafts, you never actually get the full movement back. So you can end up with quite a severe disability. And then finally is death. But on top of that, we have all the other costs that are involved. And that could involve the factory being closed by the HSE. It's the investigations time, court costs, litigation costs, it all adds up. So overall, it's a very frightening event.
So with facts like that, I'm surprised that more people aren't aware of them. Graham, is there anything we can do to prevent or mitigate an incident happening?
Yes, no, there's lots of things we could actually do. And one of the first things we could do is making sure we've got a good single line diagram of the plant.
Sorry to interrupt. A single line diagram, what is that?
A single line diagram is exactly what it says. It's just a single line diagram of the electrical system within the factory or the plant, and it shows all the isolation points. But it's very important that that single line diagram is updated after every change to the circuitry, and it should be reviewed at least once every 12 months. We could also carry out an arc flash study and thermal studies. So there's lots of specialised companies that will actually do arc flash study for you. Or if you've got a good qualified electrical engineer, they can usually do it following the calculations in IEEE 1584. We've mentioned maintenance before, but it really is important to have a good maintenance programme just to make sure everything's working properly. And again, it's a good check on housekeeping. Substations and switchgear rooms tend to be used as ad hoc storage rooms. So that's the physical side. On the people side, we really need a good electrical safety program. And that means regular training, both practical and theory. We should also be looking at training people for what to do in the event of an accident. And also, I'm a great believer that people who work with electricity should be able to do first response, i.e. breath of life. And then finally, to make sure that the system is all nice and healthy, we should be looking at doing electrical audits and electrical inspections. We also need to make sure that the safety risk assessments for the electrical system are current and have enough depth. And again, it's one of the questions I always ask, well, does your electrical safety risk assessments cover things like arc flash? Job safety briefs, again, I'm a great believer in this. What I found from a lot of accident investigation, there's also been a communication issue. So it's really defining who's in charge, what are we going to do, who's going to do it, and again, importantly, what's going to happen if there is an electrical accident. And finally, really, we ought to be looking at distance as your friend. So if there's no need for you to be in that switchgear room or in that substation, why be there? If you can operate the equipment remotely, operate it remotely. And then finally, the very last resort, as we all know, is PPE. And I would strongly recommend people get it and they wear it.
Thanks, Graham. So there we have it, the myths, facts and folklore surrounding arc flash. After everything that Graham has said today, I want you to ask yourself whether you can confidently say that your workforce is protected against an incident like we've identified. If you have any doubts, then register for that free electrical safety health check that I mentioned earlier. The time it takes you to complete the form could make the difference between life or death. If you have any queries or questions on today's topic, then please don't hesitate to contact us. And like I mentioned, we'll be emailing you with all the links and the information and the date on our up and coming surgery. So that's all for now. Graham, thanks again for taking part with us. And all from all at Scanware Academy, we hope to see you again soon.